Non-prismatic beam is a type of beam with varying cross-section along the beam length. In this example, we have a 200 mm width cantilever beam with depth varies from 800 to 600 mm over the span of 4 meters. The modulus of elasticity of beam is 20 GPa. The beam is subjected to uniformly distributed load of 7 kN per meter. What is the deflection at the free end of this cantilever beam? First, let's determine the support reaction of the beam. As a result, the bending moment is 56 kN, while the vertical reaction is 28 kN. Then, we determine the internal moment function for the beam. One function is enough as the loading is constant throughout the span. Since the cross-section of a non-prismatic beam changes with location, we need to segmentize the beam prior to analysis. In this example, we divide the beam into 4 numbers of 1 meter length segments. Then, we construct a table to outline the cross-sectional properties, namely second moment of area and the beam internal moment for every 1 meter ordinate. With these parameters, we can calculate m/ei for each point. To calculate the deflection of a non-prismatic beam, we may use conjugate beam method. We develop a conjugate beam based on support condition. For this example, the end condition of conjugate beam at point A and B is free and fixed respectively. Then, we treat m/ei as loading acting on beam. Recalling that we have segmentized the beam, it is necessary for us to mark the load magnitude at every 1 meter ordinate. Finally, we calculate the internal moment developed at the interested point to determine its actual deflection. The moment at fixed end of conjugate beam is the product of load and its lever arm measured from here. To make things easier, we divide the loading diagram into 7 parts, as shown here. The magnitude of load by each part is the area of that part. Meanwhile, the moment induced by each part is calculated by multiplying the load magnitude with the distance between area centroid and fixed end. We have no issue for rectangular part, namely A, C, and E. For remaining parts, we may regard them as triangle. Such assumption eases our area and lever arm calculation, and yet still can produce pretty accurate result. Let's construct another table to make everything clear. First, we calculate the area of each part. Then, we determine the lever arm. Next, we calculate the product of area and lever arm and obtain the bending moment contributed by each part. Finally, after summing the bending moment contribution, we determine the total bending moment developed at the fixed end of conjugate beam. Now, we know the beam deflection at free end is 1.55 mm. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.